Concrete is at the very foundation of the modern world. After water, concrete is the second most consumed material on the planet, with a colossal 30 billion tonnes of the stuff used each year, and that figure is only going up.
Despite the fact it holds the modern world together, concrete has a serious emissions problem.
Concrete production accounted for more than 8% of all greenhouse gases in 2021.
If we're going to limit climate change to 1.5 degrees C by the end of the century and build the buildings we need to be resilient to climate change, we're going to have to seriously rethink how we use concrete. So what exactly is concrete?
In basic terms, concrete is made up of stones, sand, cement and water. Mix the four together, wait 28 days, and voila, concrete. Concrete's friend and foe is cement. It's a white powder that, when added to the water, reacts to form a powerful binder that glues the sand and stone together. It's also the source of 70% of concrete's emissions. The reason is that to make cement, limestone and clay have to be cooked in a gigantic kiln. The kiln is heated to over 1400 degrees C, and that heat is created by burning, you guessed it, fossil fuels. Then a reaction takes place inside the kiln, known as calcination, which produces carbon dioxide as a byproduct.
Given cement is so carbon intensive to produce, finding an alternative binder is a key priority for the construction industry.
One company taking on the challenge is Carbocrete, based out in Montreal, Canada. They've created a novel cement-like binder that actually sequesters carbon dioxide.
So we replace cement with something known as steel slag, which is an industrial waste byproduct of the steelmaking business. We grind it up to the consistency of cement and replace cement in the mixture 100%. We remove about 55 kilograms of CO2 per ton of concrete, whereas regular concrete is carbon positive by approximately 200 kilograms. This is a concrete masonry unit. It's 18 kilograms. Normally there's 2 kilograms of cement that go into it. For every kilogram of cement, there's a kilogram of CO2 that's emitted during the manufacturing process. So with our technology, you avoid 2 kilograms of CO2 emissions, and then we actually permanently mineralize within the product during the curing process about 500 grams of CO2. So that's how it gets carbon negative. It's about the same cost as making regular concrete. So I would say that we'll be using our technology in buildings in the middle of this year.
This carbon-negative concrete could be an extremely promising development, given the scale of concrete use worldwide. One estimate found that decarbonising cement would have more impact on emissions dollar for dollar than decarbonising aviation and shipping.
Over at the University of Bradford, Professor Ashraf Ashur is rethinking how we use concrete.
Currently, at the end of life of any reinforced concrete structures, the structure is destructively demolished. It was estimated that UK producing around 60 to 70 million tons of demolition waste. So our main aim to produce green concrete from construction demolition waste. We start by collecting the demolition waste, demolished bricks, demolished concrete, demolished glass tiles. We start crushing, grinding each. And then this powder with alkali activators, we converting this to a geopolymer binder, eliminating the use of cement in producing the final concrete.
While the decarbonisation of concrete at a global level has clear economic and technical challenges ahead, the benefits of doing so far outweigh the costs.
Unfortunately, there is no one silver bullet for concrete's carbon problem. But with work carried out by Carbocrete and Professor Ashur, there is huge potential for greener concrete in building a sustainable future.